Hello. In this video, I will give you a quick demonstration on creating a secure login form using Java. Now, web security is a very complicated and evolving topic. This video is not meant to be entirely comprehensive, as many security flaws are advanced and complex, and making a perfectly secure application isn't even feasible in many cases. Use this video as an introduction to login security, but by no means a be-all and end-all. In this example, I will be using Java 7. We will be making use of servlets and the Java Database Connector JDBC. We will be using HTML5 for the client-side views, JSPs. HTML5 also allows for quick and easy form validation. If you are unable to use HTML5, then validation of information in your forms can be done through JavaScript functions. Finally, we will be using a MySQL database running on our local machine. It is important to note that another alternative exists to using Java for logins, and that is PHP. For our example, however, we will stick to using trusty servlets. These are the most common login security threats. We will cover all 5 in various ways as we attempt to make our secure login. There are 3 main areas of focus when dealing in login security. Firstly, we will need the client-side view to be up to snuff, as this is one of the most obvious and available parts of the system that an attacker could break into. Let's take a look at a very simplistic login page. As you can see, we have a form with 3 HTML5 input elements, a text field for username, a password field for password, and a submit button to submit the form. Our form itself has an ID, an action to direct our HTTP request, and a method. A login form must be submitted using the post method. The other option, get, concatenates the values of your inputs into the URL itself, a huge security hole if you were to submit your login form this way. The action of our login form is currently set to login, which is the URL mapping of our servlet login controller. Depending on this version of servlets that you are using, your servlet mappings will either need to be explicitly stated in the web.xml file, or will be done automatically through the use of servlet annotations. Annotations are the latest way to map servlets, and this is generally preferred. An incredibly useful addition to HTML5 is client-side validation. Previously, JavaScript code was needed in order to validate inputs through the client. However, HTML5 allows us to add a simple required attribute to the input element, which prevents the user from skipping fields entirely. For example, if we hit submit, the client catches our error and notifies us. Finally, another important HTML design choice that we've made is to make the input type for the password field a password HTML type. This stops one of the simplest security issues from occurring, someone looking over your shoulder. As you can see, instead of plain text, our input shows up as little bullet dots. On top of that, the password input type does not allow a user to copy and paste a password in order to steal it that way. The last thing we have on the page is what is known as JSP expression language. Putting a $sign with brackets is a shorthand way of grabbing a Java object and displaying it to the page. This is useful for our POJOs, which the expression language can use to access the data of specific fields of those objects. As you will see in a minute, error message is referring to an object that we've placed in our request scope as an attribute. That's all there really is to it for client-side security. Now, let's take a look at setting up our database correctly and securely. For this example, I've created a database schema called Secure Login, and it has one table, user. Our user ID is set to auto-increment, be unique, and not null. This means it should never overlap with any other user ID in the table. Our username column stores the unique, not null username. Finally, Our password column stores an encrypted or hashed version of our password. The most important aspect of a user account system is how user passwords are protected. User account databases are one of the most frequently hacked, so you must do something to protect your users' passwords if your website is ever breached. Storing the password directly, known as plain text, is out of the question. The best way to protect passwords is to employ what is known as password hashing. There are multiple algorithms available to use, some of the most common being MD5, SHA-256, or SHA-512. But there are only two types of encrypted passwords, salted and unsalted. Salted passwords are more secure, but more difficult to implement. In this sample example, I will be using an unsalted SHA-256 algorithm, which gives us basic protection from hacking attempts. I will explain in detail how to hash our passwords when we take a look at the servlet. Now that we have our table set up, we can go back to our open project, and you can see we have a POJO for user, an object representation of the database table. This simple class contains fields that are related to the database columns. On top of that, we've added a user helper object to handle the database connectivity grunt work. This follows the separation of responsibilities paradigm, which in itself is a security measure. Let's take a look at how the helper is handling our database. First off, you will notice the standard helper class database connection. In a true login system that would be going into production, this connection should be securely set up, ideally using SSL. The standard configuration of MySQL is intended to be as fast as possible, so encrypted connections between the client and the server are not used by default. This means that someone with access to the network could watch all your traffic and look at the data being sent or received in a process known as network eavesdropping. MySQL supports SSL, which is a protocol that uses different encryption algorithms to ensure that data received over a public network can be trusted. It has mechanisms to detect any data change, loss, or replay. Setting up this connection, however, takes a lot of effort, including setting up security certificates and configuring the data server to accept SSL connections. In the interest of simplicity, we will continue to use the default MySQL implementation, but it is important to know that any login system you create would need this HTTPS encryption. In User Helper, you will also notice the use of prepared statements. Let me state this very clearly. Never ever use regular SQL statements when using parameterized queries. These open up an application to what is known as a SQL injection. These vulnerabilities allow an attacker to inject or execute SQL commands within an application. It is one of the most widespread and dangerous application vulnerabilities, and can be almost entirely averted through the use of the simple prepared statement. For example, an attacker could implement a SQL injection by entering a SQL-style code into the username box. Depending on the SQL entered, if the helper used statement instead of prepared statement, the input SQL could be misinterpreted by the connection to return a specific user without having entered the proper credentials. Finally, let's take a look at some more server-side functionality and how we're making it more secure. Once the user hits the submit on the login form, their current session is directed to the login servlet, called the login controller. Since it is a post request, our doPost method is called. One of the first things we check is our number of login attempts. Doing so prevents against the next type of security vulnerability, Brute force attacks. A brute force attack is exactly what it sounds like. A user uses the speed of a computer to try millions upon millions of combinations of usernames and passwords to force their way in. Limiting the number of failed login attempts effectively destroys a hacker's ability to perform this attack. In our example, we are storing the number of login attempts as a variable in the session. This is done for simplicity and ease of implementation. In reality, a hacker could just switch to another web browser, or clear their own local data to reset their login attempts. A more robust implementation would store the data in a table in the database, which would include an IP address and date and time last accessed. Another popular alternative is the implementation of a CAPTCHA. An awesome free CAPTCHA, known as reCAPTCHA, is Google's own implementation. If you own your own website, they will allow you to use their free CAPTCHA by just adding a few lines of code to your site. This effectively deters many brute force attacks you may encounter. Continuing to look at our code, if we have not exceeded our login attempts, then we proceed. Firstly, we gather the information from the form fields. Then we proceed to hash the plaintext password we received. We do this through a class I've set up, known as password service. This class has one method, encrypt. Java gives us a pretty easy way to encrypt through its security libraries. First, we create what is known as a message digest. This message digest object is what handles the encryption of our password behind the scenes. We begin by telling it that we want to use the SHA-256 algorithm for our encryption. We then pass our unencrypted password's bytes to the digest. Next we call the message digest's digest method, which hashes our password and returns the hashed password as an array of bytes. Finally, we convert our byte array into a usable string and return. Going back to our servlet, we use that hashed password to compare it to the hashed password stored in the database. If there is no match, then we update the login attempts and display the error message. If, however, the user's credentials are legitimate, we then have our last two problems to tackle. The next two vulnerabilities we face are what are known as session hijacking, or session fixation, and cross-site scripting. A common problem in old implementations of websites was the fact that a user's session ID never changed. Unsurprisingly, it is actually incredibly easy to figure out your own personal ID by looking at your local private data, such as cookies. But it is also easy for outside parties to steal that info, even just through the client. This can be done through cross-site scripting, which we will discuss in a bit. Now, session hijacking poses a problem if our authentication key, session ID, never changes. Take for instance an anonymous user who jumps around the site, but isn't logged in. Depending on where that user visits, they could unknowingly be subject to an attack and have their session ID stolen. Now, if they were to log in with that same session ID and gain extra user privileges, the hacker would have access to those privileges as well. Looking at line 90, you can see that we have invalidated our current session and created a new one as soon as a user has successfully entered correct credentials. In this way, the old key is useless, and the hacker does not have the new one that has been assigned to our user. Leaving the ID the same opens up the ability for a hacker to gain up to admin privileges and basically full run of the site. Along those same lines, if a site is suffering from a cross-site scripting attack, a client can steal your session ID without even going through the server and without you even knowing. Depending on how the web app is laid out, it may be possible for a user to inject scripting code onto your site to perform malicious operations. In fact, it is possible for them to currently inject script into my own site. I'll run through an example. As you can see, I haven't created a Create Account page. Let's assume that I made that page so that when a user creates a new account, that the form for the username does not have any sort of character validation. For example, I can freely include brackets, parentheses, quotations, and other punctuation into my username, and that will be valid. Assume that in user creation I created an account with this username: script, alert, hello, close script. On our account page, once we have successfully logged in, we have an expression language expression that puts our username on the web page. Since our username is a script, that script will execute once it is in the page. Once I log in, an alert will pop up that says hello. This seems harmless enough, but cross-site scripting can be very powerful and could allow us to steal various information, including a user's information stored in local cookies, redirect a user to a website that they didn't anticipate, or embed malicious scripts in what appears to be a legitimate site. If we take a look at the source code for this page, we can see that our script has in fact become embedded, as it is our username, and that the alert message with hello has been run as soon as the page was loaded. In order to counteract cross-site scripting in our login, we would need to put a few parameters in place. We should first limit the length of usernames so that users cannot freely enter paragraphs of text as a username. 8 to 16 characters should be more than enough for a user to create an interesting name, but limits the damage a potential hacker could do. In the creation form, we should also not allow strange characters in our usernames, including brackets. Finally, we should utilize what is known as sanitizing or escaping of input data. If we sanitize our data, it means we clean the input to avoid code conflicts, security issues, or other issues that might arise from non-standardized input and human error. This could mean removing vulgarities and odd symbols from the text, or escaping specific character strings such as script so that they don't end up being executed in the browser. Well, that about wraps it up for creating a simple, secure login system. Thanks for watching.